I don't know where our first speaker is, dude. So.
All right, no problem. I just started the. Oh, and this mic's hot. Check, check, hot mic. Just started the live stream. Use your picture.
Okay. Isn't that horrible? I was like, are the women gonna get mad at me for this? No, they
Only the grandmas.
only the grandmas, right?
No, grandmas like to be appreciated.
Yeah.
So if we did it tonight, I have to ask people not to do a snapshot or post it.
Okay.
But I can do it next month too. So that's
Yeah.
next month probably better.
Well, I think we're just started a live stream, so.
This mic, it might be streaming out to YouTube.
Hey, we have 0 viewers at the moment, but.
We'll do it next month when I have no.
Next, okay.
There's no worries on terms of feedback.
All right. Let's plan on it then. Yeah, it'll be March.
Okay, I'll send you a little write-up and all that good stuff.
Yeah, please, because I'll forget. I mean, not meaning I would, but yeah, I know myself.
Yeah. Yeah.
So in theory, we've got something that we've never had in SVVR before. Is that I'm pulling audio out of the HDMI. We're on this. Just our front entrance faces the street. I feel like when you don't tell people that, then they figure it out.
Front entrance faces the street. Everyone's waiting for you, but don't stress about it.
Entire meetup is sitting here looking at you.
I always give I give Mo a more hard time. It's so bad. I'm so bad.
I feel like that should start streaming. Is that taking so long? We should have moved past the large mark picture. Anyway, we are pulling audio off the HDMI if people have presentations and mixing it into everything.
Okay.
Which is something we've never had before, so finally got that connected.
Oh, there we go.
Okay. Oh, good. It sounds good. The audio sounds good. Actually sounding better than any SVVR sounds. Because I actually had to focus just on the one thing.
Okay. Maybe I can just. Maybe I'm already on your Wi-Fi.
Presentation, can I do just a little like?
Yeah. No. You're first. SVVR Studio. You're first. Do it. I want you to talk about the co-working thing and the membership thing and the. Yeah. No. This could be the. Where did we start out at? What was the place? The Hacker Dojo. This could just be. Well, I know. Yeah. Okay, what's it now?
There's a video. Looks good. I mean, for what it is.
Yeah. Yeah, the lighting's
not good, but it looks okay actually up here.
Oh, there was someone in front of me. That's
so
why.
You can actually see the person.
Yeah. All right. So, what do I type here?
Oh, SVVR 2018 exclamation.
Okay.
Presentation. Yeah, that looks okay.
Okay. How do I get that?
Lights, that looks okay.
How do I get that URL?
So I just tweeted it out, or I can text it to you.
Yeah. Maybe. Yeah, I think text will work. Then I can post it on our stuff.
Oh, I accidentally called you. I meant to text you. Oh, I accidentally called you again. Like, just trying to send the message here.
Hey, I'm Shannon.
I mean, and there it goes.
Oh, hey. Oh, good. Cool. Yeah.
So yeah, that's the test, right?
Yeah, man.
And just make sure that my computer fits with your
Okay.
fittings.
Come check it out. I think.
I guess I'm your tech support tonight.
Dude, you're the AV guy because I don't know your system. So, oh, I see.
HDMI?
No, I just got those.
USB-C.
That's right.
Oh shit! I bet you don't have that yet.
Bill Most, yeah, we probably have it somewhere.
Really?
We know kind of now. We've never actually had a presenter.
Get with the times, man.
Tell the presenters to get with the times.
No, they are with the times. They're ahead of the times.
Live in the dongle life.
Can I move some of this?
Sure, man.
And but do you want to keep that one?
I know, we need a bigger, we need like a wider podium here.
Yeah, that's probably good. Be careful. When do you want this to start?
So it'll be me do the intro, then Carl will talk a little bit about SVVR, and then you're up first. And then
Let's just make sure it shows.
we'll have Ricardo if he shows up. I think they were lost.
Okay.
And yeah, you should be good. Oh, there, you just unplug. You need HDMI, I think, right, to this? Yeah.
Should be.
Let's test it.
Please.
Up. We got an hourglass. Boom! Skadoosh.
Okay, great.
Cool. All right, so give me this. Go to this.
You have power here.
Oh, good to see you, man. Nice. Did you like my company message I put? No, I know. The first time they're getting sighted. It's just it takes time. SVVR 2018 bang. No. No, I went
Usually
through
when I
this.
say bang, people are like, what? But I feel like these people have everyone here would know.
Hey, man. Dude, I had a meeting at NASA today.
About what?
Well, one of the things that came up was they really want to commercialize it and get investors to actually fund some of the research that's going on.
They have like a huge program for those. In the case, it's a special organization between NASA and startups.
Yeah, no, this is NASA itself asking for this.
Yeah.
So I'll tell you about it more. And
then Rusky is director of that center here at Ames.
so, you know, like $2.5–3 million kind of things. All right, let's get everybody. It's like a big vision. Hey.
Hello. Thanks for organizing this.
Yeah, man. It should be fun. Yeah. I felt really bad buying 8 pizzas. I have a pizza addiction. I'm sorry. Oh, come get like 30 pizzas. We did? Yeah, we'll run out. No, it's fine. You shouldn't be eating pizza anyway.
I just wanted to try my computer.
Let's do it, man. Yeah. So are you Mac
Yeah.
with USB-C?
Yes.
Ta-da! No, we have an adapter. He has it.
No, I have to.
Yeah?
Should be. I even have an USB-C to VGA.
What? There is such a thing? Oh my God. To like
all
RS-232.
Not yet, but like. Yeah,
I have a USB-C to RS-232 adapter.
To the Secret of Asia, because was it like Bangkok? Like, people there are still using VGA, or like there has to be an inverter somewhere. It's amazing.
It's always annoying when they come out with all the new connectors, right? But after a while, you kind of go, okay, well, I bought all the stuff.
If only they had a headphone speaker with USB-C.
So yeah, you can decide the order. If you want to do the WebGL updates, we have fewest, most lame demos. So if you want to have them in order increasing impressiveness, you want us to go first.
Really?
If you don't care, go last.
Yeah. Okay.
I have funny things.
Let's see. What's your password?
No.
No. All right. That's pretty slick, huh? Oh, you got your own.
No, that's fine.
Do your own, man.
Okay.
I don't want to touch your dongle anyway. No, man. We're just gonna check. MrDoob's gonna check his dongle. It's just
Is
too
there a
fun to
Wi-Fi
talk
here?
about. Yeah. SVVR thing. See that?
This one?
Yep. SVVR 2018. Bang. Yeah. Dude, is there a problem with the GLTF loader and shaders and textures? Do you have to load it separately or something weird?
Shouldn't be.
Okay.
running a web server?
I was actually using A-Frame's implementation of it, so I
Right.
don't know what they're doing. Maybe there should be someone here that knows A-Frame. I was just playing with it last night. I have a GLTF that's got it all baked in, the texture, and it won't load.
The texture won't load?
Texture won't load.
But are you running it, are you setting up a web server to run it, or are you running it from like, okay.
Yeah.
And
Yeah. Yeah, it's frustrating. And I don't know how to debug it. What do you,
what do you do?
What do you do, man? We need Diego. We need to move the
One of the
Diego.
Diegos is coming. One of the Diegos.
There's more than one Diego, I realize that tonight.
Yeah.
Is what? Is
Yeah.
what?
Yes.
Supposed to say yes is what?
All right. Is there a room I can go to? I have to finish the slides.
Really?
Yeah.
I don't know what's behind there, man. There's little offices. Go over there, one of those
Okay.
offices, man.
I'll do that. So, what's the order then?
I'll make you go later,
Okay.
because you got to go do your work, right?
Yeah.
All right.
How long are the talking moment?
I could totally set you up right now.
Right now?
At first
he's
on the
starting.
list is ta-da.
And then I'll
Yeah.
I'll do the same thing.
I could kill you. All right, so probably in a half hour.
Okay.
All right. Scanning. Yep. So, we're saving to YouTube, yeah? Yeah. Okay. So I'll just do it later. I never was able to post it. That is totally not my computer. What's going on here? That's Ricardo's computer, dude. How is that possible?
Did something lock? Something might have froze on.
Yeah, that was his screen. Hey, well, welcome to WebGL, WebVR, and at SVVR new headquarters. I mean, check it out. What an amazing space. What do you guys think? Right? I mean, I can't imagine like a better location in the center of Silicon Valley and like all these developer community around here. Everybody's like, it's like nerd headquarters right here, man. So, so we still don't have a thing, but yeah, I don't know what's going on. Oh, that looked good. That looked promising. So, yeah, I think Carl's going to talk about it in a minute here. Maybe we can jump to the. Oh, there we go. We can go up.
Where is this?
It's in that room over there. I'm not kidding. How about you? All right, so let's. Yeah, it's a bizarre land.
So this one and then back. Something crashed and that image is frozen somewhere
Yeah.
along the line.
Yeah. Yeah. Okay. Dun dun dun. Ooh.
No.
So maybe yours won't even work either for your Prezzo. So our next meetup, by the way, is going to be at GTC, the big conference in at San Jose Convention Center. And just in case you don't know, when you attend that meetup, you get a free ticket to GTC for the exhibits for that day.
Now it's a little bit of both.
It's a little bit of both. All right. So it should be a good meetup, and it's cool to go in and see. And it's not just for all you Bitcoin miners to go to GTC, right? It's actually a useful event, and it's interesting. So let's see, we have that. I'll just talk. So I wanted to announce there is an upcoming hackathon coming up in March. It's called, Damon, help me out here. Creating Reality. It's called Creating Reality, and it's going to be at USC, and it's put on by the same guys that did the MIT Media Labs hackathon, which myself helped with substantially last year. I think Damon did the year before, and awesome hackathon. And the thing that's cool about it is that there's actually real prizes for the winners. So it's VR specific, or AR, VR, WebGL, volumetric photogrammetry, any kind of wacky cutting edge technology. And the prizes that came out of it were like $5,000 for the grand prize winner, $3,000 for the second prize winner. HP sponsors it, NVIDIA sponsors it. There's a lot of like corporates there, and it's a really good hackathon because people don't just show up with well-formed teams already. You get there and you kind of form your team on site and go off and do it. And it's not like you have to one of these 24-hour hackathons where you kill yourself for days on end. I think it shuts down at like 11 p.m. every night. Get a night's sleep. You show up at 3 a.m. No, just kidding. You show up. Show up at 8 a.m. and continue on, right? Oh, there we go. Thanks. So yeah, and as a result of the hackathon before, the one Damon did, I think 3 startups came out of it that continued on and made companies. So if you're into hackathon kind of thing, please come down to USC. I'll be down there mentoring. I think Damon will be there too, and it's going to be cool. Totally. American Steel, Burning Man Foundation right there. Okay, next, okay. I was playing with A-Frame last night, and I'm having trouble with loading a GLTF file. If anybody's into A-Frame and GLTF, help me out. I couldn't get the texture to load, man. Is Diego here? I don't know. Anybody? Somebody please help me. I'm struggling. Okay, so tonight's lineup, we have Uber, going to talk about some cool, like, data mining, machine learning stuff, I think, yeah? Visualization. I'm excited to hear. And we have the Chrome team, we have MrDoob, and we have some community announcements. And we Chrome and Firefox team. Oh, hey, welcome. So first off, I wanted to let Carl Krantz, founder of SVVR, give a quick announcement about the space and about SVVR and the goings on, and then we'll continue on. And by the way, yeah, we're recording this, so.
Gonna work. All right. What I learned tonight is that a projector can crash and just lock with the image no matter what you feed it. All right, so hi everyone. I know many of you, I don't know some of you. Welcome to our new SVVR studio space here. For those of you that don't know, SVVR, Silicon Valley Virtual Reality, we started as a meetup group way back in 2013 right here in Mountain View. We've been bouncing around for years, and we are now back in Mountain View as of just about a month ago in this new space. Welcome.
We are, the point of this space is to provide, first and foremost, a mixed reality event venue, so a place that we can do our meetups, because our meetups we do them every month. We've been doing them for almost 5 years now. But also a whole bunch of other things to be a VR makerspace. We have hardware library, showroom, a lot of demo rooms for VR, and a VR museum in the front that we're setting up. And also co-working for folks in the VR industry. So in order to do that, we launched a new program just when we moved in here called SVVR Passport. And this is a membership network for VR professionals. So if you're in the VR industry or somehow related to VR, AR, anything like that, you can join this space and you get 24/7 access to this space here. That includes, you can book demo rooms, you can book meeting rooms, you can use the space for co-working, and you get access to our equipment library, some community stuff, discounts to events, all sorts of things that we offer. So this is, it's a little more than just co-working, but it's similar to a co-working deal. But it's only $150 a month for an individual membership. Includes all these things, and you can even get it down to $125 with a 1-year commitment. So if you're interested, please see myself or Nana at the front desk there. That's Nana waving over there, my partner. We would love to have anyone working in the space join our community. We have an awesome community here. We also have company memberships. It's just a little bit more, $2,000 a year, and basically the only difference there is that you still get 1 seat, but you can send someone different. If you have a couple co-founders, you can switch off depending on who's available that day or who needs access. So that's pretty much it. Let you guys get back to what you're doing here, but thank you all for coming, and welcome, and enjoy. Okay.
Yeah, I don't know if you guys know, but SVVR was really the model for this WebGL meetup, and yeah, we kind of share logos a little bit, and kind of sister organization, little branding brothers. That sounds kind of weird. So anyway, so first up, I guess we're going to do Mozilla and Google. Give us an update on what the haps on WebGL.
So would all of the browser folks come up, please? Sweet. HDMI. Will this work? Will it work? Yeah. VGA resolution, awesome. Oh, okay. All right, neat. So please come up, line up. So hi, we work on browsers in WebGL. Can we let's make room? Figure out. Yeah, come on, don't be bashful.
Sorting is a hard problem in computer science.
Yeah, we'll do the n-squared.
This is called a chaotic search.
Yeah. I'm the odd one out. Jeff Gilbert. I do WebGL at Mozilla. I'm Kai. Kai Yanamiya. I work on WebGL at Google and WebPTA.
My name's Ken Russell. I work at Google on Chrome and on WebGL.
I'm James Topinian. I also work on Chrome and WebGL.
Mo, also Chrome WebGL.
So if you have any questions or complaints or bug reports, you know where to find us. We'll be here all evening. So yes. And so we have a brief update for you. Anybody else want to speak to this?
You got this, Ken.
All right. Okay, so we continue to resolve several corner cases in the WebGL spec and in the tests. And the work is mainly focused on letting the browsers pick up the Angle library, which some of you may know. This is an underpinning of WebGL in browsers, and allowing that library to directly implement WebGL version 2. And all this work is basically leading toward getting Microsoft's Edge and Apple Safari browsers to finally pick up and implement WebGL 2, so it's finally ubiquitous across all the browsers. And of course, we have nothing to announce at this time, as you may know, because we don't pre-announce anything from Microsoft or Apple. And it would be premature anyway. We continue to focus on quality, on continuing to fix bugs reported by WebGL developers such as yourselves and found by fuzzers. We also report the bugs upstream to graphics vendors and operating system vendors as is appropriate. We are adding more tests. Kai, please say hi. Kai's just ported a whole bunch of WebGL conformance tests into the Android conformance test suite so that the drivers are going to get better in your phones.
Imperial College of London is doing a bunch of shader fuzzing. And by the way, these slides will be linked from the meetup. I already sent you the link, Shannon, so that you can see what's going on there. But they're finding crazy stuff by like changing a WebGL shader to do +0, or like if false to return. And these no-op transformations break graphics drivers everywhere. It's insane. So we continue to fix these issues as they're reported. We are working on speeding up videos in WebGL in support of 360 video in WebVR. So we're sorry it's taken so long, but we're working on it. We want to add extensions to allow you to better batch your geometry so that you can do stuff like Brandel was just talking about, lots of text in WebGL with one draw call so that you don't bounce back and forth between JavaScript and the C++ code. And it'll speed things up even if the driver doesn't actually support the extensions. As long as you can sort of get out of JavaScript and do all the work under the hood, it'll be faster. And there's some pretty neat stuff coming out. You should follow tons of people on Twitter. If you look at Patrick Hosey's feed, they've got a really neat video, which we can play a little bit of, but they're doing like, WebGL for autonomous cars. Yeah, and like sensor simulation, crazy stuff. So this is all linked from the presentation, and you should go check it out. I want to show you Hector. Is it Hector Arellano? I'm not quite sure how to pronounce this, but he's simulating fluids in WebGL using WebGL version 2 and using 3D textures as the basis for the simulation. It's slower than real time, even on a super high-end GPU, but it's still really neat because you can run it in your browser. Felix Weitzel has been doing particle simulations in WebGL for a really long time, and he's got this another crazy new one that does. It's super fast too, but it's like the particles repel each other so they don't actually collide, but they follow your mouse and you can get all sorts of neat effects. Very trippy, so you should go check his stuff out. This is live. This is real. Yeah, so you can do all sorts of crazy stuff. And of course, Shader Toy continues to push the boundaries of what... Oh, darn. I didn't log in here. Okay, go away. But yeah, let's see here. Tons of crazy visualizations, and these are all ray-marched, right? So there's no real geometry. It's just two triangles that are implementing crazy effects like this, and they're fast, too. So this one, for example, is really nifty. Very Tron style. So lots of cool stuff out there. I'm sure that you're all doing awesome stuff too. I just didn't happen to see it before the meetup. So please post your stuff to the meetup page to get your work out there. And again, please come and find us after the presentation so that we can chat and find out what you're doing and how we can help you make it go faster and with fewer bugs. So thanks. And if you haven't gotten a WebGL t-shirt from one of the previous meetups, please come find us after the presentations. We have them in ladies' sizes and smalls, yes. Yes.
Okay, next up is Uber. They're doing something with cars. I don't know. Should be interesting.
All right. Hey everyone. I'm Ib Green. I work at the visualization team at Uber, and we specialize in WebGL, and we use it for geospatial visualizations. And so, if you think about it, right? I kind of sometimes when I think about Uber, kind of think about it as almost a planetary scale transportation machine. And you can imagine with enormous amount of trips that we have, and the fact that all of these are activities that happen somewhere in the world, the amount of data that we generate. And so for us to understand this data is crucial, and so visualizations are very important. And the data is very big, and so, and for convenience, you really want to work in browsers, and so WebGL for us is a really powerful tool. And so this is going to show you a little bit about about what we do. And if you think about it, right, the size, it's big data. So this is just a typical query You know, it's all anonymized data, but this could be like 200,000 trips in San Francisco, and suddenly, you know, you need to do something with this and get some insight. And what we do, you know, what we in the visualization team try to do is we try to use visualizations to bring insights into this data. And here we have the same data being visualized in 3 different ways: as a scatter plot, you know, as a set of arcs, and as a set of hexagons. And it might be a different column in the table, but if you think about it, right, in the first one, the yellow heat map, you might be able to see, you know, a density where, you know, cars are driving, and so on. And you can basically make certain type of congestion analysis and so on. In the second one, where you have the arcs, you may be able from the same data to extract information about the flows, where people are coming from, where they're going to, and so on. And in the third one, let's say that represents, you know, the pickup areas, the pickup points, right? And that kind of heat map might give you an indication of the coverage that our service has, you know, at that time and place. So since we keep doing this again and again, and we help a lot of team, the visualization team helps a lot of team build tools for this. So we've created a set of frameworks and we've open sourced them. And so the most important of these frameworks is WebGL, and it's getting some traction on GitHub, so you might have heard about it. And so it is, you know, it's a WebGL library that has been created with a very kind of singular purpose. So it's really, so maybe what I'm kind of trying to describe here, we are very visualization focused, so it's about rendering big data. We are, you know, kind of geospatial from the ground up. And so, you know, if you have anything that's longitude and latitude, which can be a little bit tricky to kind of make sense of, we're going to talk more about that, you can just throw it into this library and it will do the right things. Another thing is we also have done a lot of work on the hybrid parts, and come back to that. Links to the kind of automotive self-driving car and so on that we saw before. We'll take a look at that, what that means. And then another thing that we've also focused on in this library is that we have a very strong trend now with doing basically functional programming through libraries like React and Redux and so on. And doing that with a traditional WebGL library can be quite challenging. And so I'm going to explain a little bit about that. And so overall it's quite complex. Of course, it's a lot of shaders, it's a lot of GPU code, a lot of, you know, geospatial projections and so on. But the basic principle of WebGL is very simple. So there's basically the idea that you have a base map, and then on top of that you put your data into various layers. There's a catalog of layers you can select from, and they provide various types of visualizations like the ones we saw in the previous slide. So there can be an arc layer, a hexagon layer, a scatter plot layer, or maybe a GeoJSON layer for showing more traditional geography. And you can compose these, you can configure these, and you can compose them in a very simple way. And obviously, the power of the framework also comes from the fact that we have a catalog of proven layers. And so some of the layers you can see here, they're actually very simple layers. So you actually have a line layer. This is a scatter plot layer. This is a hexagon layer. This is a GeoJSON layer up here. But by using props and accessors and so on, you can create, you know, very interesting visual effects with you know, remarkably little effort. And so one of the things that's very important when you work with big data is that you really want to do as little as possible with the data. And so what you typically do is you do some kind of load. It could be an XML HTTP request. You get, you know, some big array down. It could be millions of items. It could be JSON. It could be a CSV, you know, comma separated values. But when you get that in, you really don't want to start transforming it in JavaScript. That's going to kill your performance. And so what we ultimately have to do, in some sense, we do have to transform it once, because we have to take that data in your big table and map it into what's essentially vertex attributes, big chunks of typed arrays, contiguous native memory that the GPU can access, right? And so what you do in these layers, you use something called accessors. So you tell the layer how to build this, you know, vertex attribute for each of the data elements. And so it basically, the WebGL walks through all your data and extracts, you know, calls your accessor, you know, for get position. How do you extract the position from this datum? How do I extract the angle? Whatever, you know, the various parameters that the layer offers. And so very efficiently it does this pass, builds these big arrays, and then sends them down to the GPU. And just how this can look, if you're not familiar with the syntax, this is JSX syntax. It's a React extension, but basically it creates a new graph. This is a slightly different example. This is a graph class. Here you have the data, it's the nodes, so this is an array of nodes. And then you basically tell it for every node how to get the color. It's a constant here, RGB, you know, the size, it's also constant, and the position, you actually ask it to look into that element's, you know, position. It's all, you know, as you can see, ES6 and the latest JavaScript notation, but it's kind of, well, so if you think about big data, so, you know, if you're rendering millions of elements, you know, if you've kind of worked with WebGL for a while, you probably know that there can be a lot of overhead in doing a lot of draw calls. And so one of the kind of important principles in DecGL is to really leverage instanced renderings, which we've done from the very start. And so if you think about data visualizations, you can see how well suited. It's normally you talk about it as a feature for games, doing grass or trees or crowds or something like that. But we render the same thing, you know, kind of a hexagon, a point, an arc or whatever, right? Many of these layers render that again and again and again. And the hexagon can require a bit of geometry, right? There's a number of triangles, 6 triangles to make up the top, and you know, you need to have the sides and so on. But we only specify those once, and then for each instance, we only specify the center position, the color, and maybe the radius and the elevation or something like that. And so it becomes a very compact representation in memory. It's very quick to attribute. And all of these millions, potentially millions of points, we draw in a single GPU draw call. And so, you know, there's really the overhead that JavaScript or the browser adds to this type of rendering is obviously very small. Instancing is an extension in WebGL, but I don't think we've found a system that doesn't support it. And the good news, it's standard in WebGL too. So that's pretty cool. Yeah, so let's talk a little bit about what it means to be geospatially focused. I mean, from the end user's point of view, it means that you have longitudes or latitudes or other things that need to go on a map, and you don't have to worry on, you know, how these how these things are unprojected, right? I mean, geospatial coordinates are spherical or elliptical or depending on the system, and you need to kind of unproject them or unwrap them. And especially if you put something on top of a base map, right? The second bullet is about map synchronization. We tend to use Mapbox.gl, which we think is an incredible map, but you know, obviously it could work with any map that supports the same projection systems. And so so let's dig in a little bit to that. So what we typically use, you know, 99% of all maps on the web are, you know, basically use the web Mercator projection. How am I with time? Is it, yeah. And, you know, it's these very simple stanzas, right? So the first one is really just a linear thing once you've dealt with the scale, and the second is a tangent and a logarithm. So beautiful, it's a spherical approximation of the Earth. But even so, there is a tail of complications. And so there's just, you know, a lot of little things that you need to deal with. And it depends on how deep you go into it and what your use cases are. So one thing that's particularly frustrating when you deal with WebGL, WebGL is 32-bit. We only can do 32 bits in the shader. And the problem is, if you zoom to the 20th, zoom level 20, which is basically, you know, effectively 1 million times, when you start getting down to street level, you know, in a block level or street level on a map, you're actually running out of 32-bit precision range. And so you need to do a bit of trickery to make sure that things don't start wobble or behave strangely or look strangely. Another problem with this is once you want to deal, I mean, putting points on the map positions is one thing, but if you want to deal with distances, if you want to say that something is so many meters wide or there's, you know, so many meters tall, the problem is that in this kind of, because you can see how this sphere is being stretched more and more as you get closer to the pole, the distance scale really varies dramatically with the latitude, and so it can be up to, I think, 7x difference. So, you know, all of these little things, you know, on top of all the normal projections and matrices and so on that you can have, can actually be a bit of a hassle to deal with. And you know, obviously it's a 2D projection, but today, I mean, it's made for maybe for 10, 15 years ago, when we mostly looked at maps in 2D, but today all the base maps, you can tilt them. Obviously you want your graphics to be in 3D and be, you know, projected on top of it. So there's extra work needed to make that happen. And so obviously these are all things that obviously we deal with. We support a number of different coordinate systems and precision options. So you can have you know, longitude and latitudes, you can have meter offsets from an anchor, and we also support non-geospatial visualizations. So I'm not going to go into the details, but it's quite interesting world of these geospatial projections. There's also, when you work with meter offsets and so on, you're basically, you know, if you think about it, you're superimposing a rectilinear coordinate system on top of a sphere, right? And so you get an increasing error. And so we have some pretty, we do some kind of second order approximations or polynomial expansions of the errors. So we get very, very good. This is at the, or very close to the pole, 75th latitude, I think. And we have 30 kilometers, we only have about 1 pixel error. So that is pretty, it makes it really helps to use a library that has worked through some of these issues. Again, for the base map, we like to synchronize with, we like to have a good base map underneath. We use Mapbox. We have created, Mapbox doesn't have a React wrapper. We have created another library for that, React MapGL. So these are the home pages of the two libraries on GitHub, and you can combine them. All right, so we've looked at these abstract visualizations that when we're very zoomed out, and we looked at scatter plots, and we looked at arcs, and we looked at hexagons, and so on. But then what happens when we zoom in? And you know, obviously, it's kind of interesting to be able to, for us, to be able to go from the aggregated data down to the individual trip, and now especially with the, you know, big investment in self-driving cars. These are older, so these are things, these are kind of a web tooling platform that we're building for autonomous vehicle group. And these are older things. These, unfortunately, these are some of the few things that I'm showing you that's not open source, at least not yet. And so these things have to kind of be approved, and I can't just make any GIF here for you. But so, yeah. So this is basically the same. You can see that these are some of the layers. There's a point cloud layer here that shows the various, you know, LiDAR, static LiDAR points that are going around. There are extruded polygon layers. There's, you know, point cloud layers here showing what the car sees, you know, path layers. So all of this, you know, this would look like more like a traditional scene graph, maybe in Three.js, but this is actually done with a set of WebGL layers. So it's quite an extensible metaphor. And the cool thing is that this is all in, you know, geospatial coordinates. You could do an absolutely seamless zoom from this world out into the, you know, aggregated world that we looked at, you know, before. So it's all in the same system. And obviously, because you can put a first-person camera here, as you can see, you could put 2 of those, and you could put, you know, a VR kind of view on this data. So it really opens up the kind of hybrid perspective. I don't know if people here use React. What we try to do with these frameworks, or particularly WebGL, is that we try to be, we call it reactive first. We try to make sure that there's a really good React integration. We also try to make sure it's experimental at this point, APIs, to make sure that you can use this without React, but we always optimize it so that it works really, really well for a kind of a reactive or functional approach. And, you know, to me, the reactive approach, it's, you know, it's declarative, certainly. You create this layer, you give them props, but it also, you create them very frequently as your state changes. And so you really need to optimize the system for these very frequent updates. And so very briefly, how does kind of this functional UI programming or reactive UI paradigm work? Well, typically you use something like Redux or Flux, you store all app states centrally. Then whenever something changes, you know, at the drop of a hat, you regenerate a full UI description, right? You render React elements, or you render these layers. And then the system, React or WebGL, diffs this description against the previous description you rendered, and then makes the minimal updates to the real UI. In React's case, it's the DOM, like the HTML and so on. And, obviously in our case, it's all the vertex array buffers and, to some extent uniforms settings that we have calculated from the previous layer. And so most of the time, there are none or very, very few updates, even though you conceptually re-render everything. This just shows, here you render a hexagon layer with one data, right? The same ID with the new data, same ID with another data, and it detects the fact that you've changed the data and makes those changes. But if the data had been the same, then obviously there would have been no updates happening under the hood. If you're familiar with React writing components, they have a life cycle. I think they call it component will mount, component did on mount. We have a similar cycle, a little bit more suited towards drawing and rendering other layers. Something we've invested a lot in is doing the ability to do composite layers. So you can take your shader, you have a cool shader that does a visualization. You can package it up as a WebGL layer, give it all these beautifully documented little props, and have this very easily from JavaScript, very easily reusable piece of code. But now, if you have a couple of these, it sometimes turns out that if you could just compose those, you could create a new layer with a higher level set of props that you could build very quickly just by composing layers. And it requires it's a little bit tricky to do it, so there's a bit of work we had to go through. But if this is just an example, so maybe you have heard about GeoJSON. It's a kind of a de facto standard for how to describe geospatial data in JavaScript or in JSON. It's basically a JSON format. And so you typically have a set of features with certain geometries, and you can put properties on them, and then you can have like arrays of that. And you can describe points, lines, and polygons. And if you look at this picture down here, this is basically a GeoJSON layer. And the way we render that is as a composite layer. So when this is supposed to render, it doesn't call the GPU to draw this GeoJSON layer, but it actually renders a couple of sub-layers. And what it uses is scatterplot, path, polygon layer, and it takes its props here, and it starts basically mapping them. It splits the data, feeds different pieces of the data to these sub-layers, sets the visibility of them depending on the props you chose. Did you want to show the outlines? Well, then you need a path layer. Did you want it to be extruded? Well, then you need an extruded polygon, and so on, right? And then forwards all the props in this way. So through just one little file, you can basically build this very, very complex layer that we saw. The kind of foundation that we have underneath, so we have almost a kind of a stack or a suite of frameworks, and this is built, we have our own WebGL 2 engine or framework underneath that we call LumaGL, and it's a set of WebGL 2 components, and it's very focused on enabling shader programming. It doesn't really come with a big library to support various types of materials or bump maps or specular maps and stuff like that. But it has, WebGL state management, WebGL polyfills, debug support, and a shader module system. And all the WebGL 2 API is provided as ES6 classes. So if you, like me, think that the WebGL API is a little bit clunky to work with, but you would like to work very close to that API, this is a pretty nice way to deal with it. The shader module, this is an example. This is a color-based picking. You render like 1 million objects. Now you from the mouse pointer you get 1 pixel. You're going to figure out which one of those 1 million objects did you actually hover over. Well, you could do some huge, quad tree or oct tree or something. That would take a lot of time potentially to build and rebuild and set it up. Well, we use color-based picking. So we render all these instances, but we just change the color and set a unique color for each instance. You sample the color under the mouse, and then you just reverse calculate the index from that color. So this color-based picking is a shader module. It's one line of code to add inject into your shader. using this system. So this didn't work that well. So yeah, one of the things we talked about before, yes. So this is 60. So we have a full 64-bit emulation library in LumaGL, and which we use in WebGL, right? And so this here you can see at the zoom, fairly early zoom level how 32-bit projection breaks down on the left, and you can see how with the 64-bit emulation library you can continue to zoom quite a bit further into the Mandelbrot set. And so the big reason we did this is, if you look here, this is the difference between what happens when you start getting down on street level. With 32-bit collapses, right, at about zoom of 1 million. You start running out of bits in your float there. And so it's, there's a couple of really good blog posts that show how to do this kind of 64-bit stuff out there, but they all conclude at the end that there's a lot of issues with the GSL compilers because they tend to optimize away and do other, bad things. And so part of the work that we've done, apart from implementing all these functions and Taylor expansions and so on, is to deal with those issues on the different. So we kind of work around those issues and.
Can you submit, test cases for the GLSL bugs that you're finding to WebGL working groups that we can get the bugs fixed? That'd be awesome.
Instead of fixing them on our end, yeah. That'd be nice. I have a really good one for you. Okay, so WebGL 2, we're all excited about it, right? And so transform feedback, it's kind of the headliner. We started to build WebGL 2 based layers. So this is a wind map. It's actually been a finalist in a visualization, basically prize in London. It's pretty cool. We first do a Delaunay triangulation on the shader of the terrain in the US and build up basically a structure of mountains, which then kind of will drive a wind flow. Then we create a vector field layer on top of that, and also based on the same triangulation. And then ultimately we put, a particle animation layer on top of this. And so this is a GIF, it doesn't do justice to it. The resolution and the frame rate's not good, but it looks pretty amazing. And so if you can imagine this being like reusable layers that you can just basically throw your data into and use the power of WebGL 2. And this is another example which is really cool. This is, a scatter plot layer, and here you take one data array and you throw in another JavaScript data array, and it generates two different vertex arrays. But what it does, instead of just replacing and switching those vertex arrays, vertex array buffers, is that it starts interpolating them using transform feedback. And so you can see how all these points move into their new positions and how they kind of, change colors. So you get these. It's like CSS transitions almost, but in WebGL. And so you just change the prop. There's all you do is you're saying, okay, this has changed from this to that, and then this animation happens for free. We have an entire bunch of non-geospatial layers. It's just too much to talk about. This is a graph layer. You can integrate it with different, graph layout engines from NPM, modules. Getting towards the end here, WebGL is part of the VisGL framework suite. We have a VisGL homepage. There's an entire, a growing range of frameworks, all open source out there, blogs and so on. Lots of, these are examples. They're all ready to use. You can just copy. They're made so that you can just copy the little directory, do npm install or yarn, and you have an independently runnable example that you can start iterating and building from. We have something called Vis Academy. So we think we have 5 or 6 different, so this goes even beyond the examples. There is an entire page for each of these that describes, how you can build a certain type of visualization. In the next version, we released 5.0 just before the end of the year. 5.1, we're getting these built-in animations, among other things. We have multiple viewports. You can see a very crude VR style examples. That's experimental API that we have to make official now. We're trying to make an open process engagement. We have all our RFCs out on the GitHub repo. So everything we're planning to do, all the discussions are there. If you want to get engaged, we'll try to make it as open as possible. We have just released something called H3. It's a spin-off S2. It's also a spatial indexing system, but this one hexagon-based, so you can actually zoom in and further subdivide hexagons. It's pretty cool. As soon as the JavaScript bindings are released, we plan to make WebGL layers that directly understand those indexes. I couldn't add this picture, but we also are looking at adding editable layer support so that you can not only visualize these layers like GeoJSON, but you can actually have the user edit them like a map or a road network or something like that. This is a team and some resources, and thank you. Yes. So what I was trying to show there is that we have a graph layer and a set of layers, nodes, edge layers, and so on. And we have made it so that you can integrate. So when you have a graph, you need a layout engine that pushes all the nodes and so on aside. And and there are a number of different such layout engines available on NPM. And so I showed 3 of those, how they had been integrated, and you had 3 different layout engines. One of them from the D3, ecosystem powering that node layer.
So, I think it's safe to assert that React needed to be created because DOM updates are pretty slow. So it really needs to diff the updates that it's going to apply to the DOM. And that's really critical. But when you're dealing more directly with the GPU, maybe you can just issue, all the draw, like you've got that's one draw call per layer. So I wonder, how important the diffing mechanism is in this application, basically, because you're dealing with a lot of data.
Well, I would argue that it's even more important, and the problem is the creation of the vertex array buffers. So if you think about, you can have, especially if you're dealing with big data, if you have this trip of 200,000 or table of 200,000 trips, you're going to generate, so the color might be, or the positions might be 3 floats, right, per instance. And so there you have 12 bytes times 200,000. So maybe you have 2.4 megabyte, right? And so every time the data changes, you have to go in and repopulate a 2.4 megabyte buffer. And that's going to take, way more time than it takes even for, slow DOM to add a couple of divs. So you really, really want to defeat this updating. And, so we have a special system of, that's even more refined that doesn't exist in React. We have an update trigger system where you can specify that only some of these, you can say only the colors have changed, only recalculate the colors or only recalculate the positions so that you don't get like a wholesale regeneration of all the vertex attributes.
And then presumably it's like sub-ranges of that.
So that's actually something we have an RFC up on. We have never really needed it, but I think we're getting there where we're going to do, partial incremental updates. It's certainly, it gets very, you have to make certain restrictions unless you want to do almost re-implement like a complete memory management heap kind of system. But for, fixed ranges, like during an edit when you're dragging a vertex or something like that, I think it's, very reasonable to have partial updates. I see a hand.
Any of the WebGL sketches actually end up in that app? They could be user facing, or is that anything planned?
Does any of the WebGL sketches?
If you guys use WebGL internally, presumably you look at it to analyze and aggregate data.
Yes. Oh, you mean in the Uber app?
Yeah.
Oh, yeah. So we work very extensively with we have a big suite of internal tools, and we also have one external tool called Movement, where we can show aggregate traffic patterns and so on to city planners and so on, and to help them kind of design their cities or their traffic improvements, and so which uses parts of this stack. And we don't have a native, I mean, the apps are obviously not web apps, right? So the apps are very optimized for the best performance. So we don't have a native version of WebGL at this point. It comes up in discussions every now and then, but the focus so far is on the web. Okay, so two questions. One is kind of the tools and who uses them and how. And there's a lot of operations people that keep our system humming and running, and they benefit greatly from these tools. I mean, it started out, the first application of this was actually in the marketplace with where we look at things like demand and supply and surge and these things, right, where we try to balance and keep the marketplace from getting inflamed. And so it's incredibly useful, and obviously you want to be able to zoom in and and zoom out and see the big patterns and do playback and things like that. So that's one example. There's an entire range of tools, maybe almost 24. I mean, I think essentially every flagship visualization tool in Uber is now moved to this stack. The second question was, does 3D help in this analysis? And so I think that's really, the traditional school of visualization. If the Tufte kind of has this concept of chart junk. So when you do visualization, it should be really, really stark. You should remove, you should have the pastel colors, and you should remove anything that's kind of a distraction. And obviously, when you're a purist like that, anything that's 3D is like automatically distraction. And so there's been a certain amount of resistance to this approach, but at the same time, I think when you do it right, I think people find it incredibly engaging. It's much more fun to interact with this data. And in some cases, when you really go down and do autonomous cars and so on, it's obvious you're dealing with the real world. I mean, why would you make it abstract? And there you kind of have to start thinking about what other things how do you clearly show which things are artificial, and how do you show the things that are using different types of forms and shapes and colors and so on. But I think we have proven, at least in our world, that 3D has a value in visualization.
When WebGL is rendering plain text, are you able to make that text available to the user or selectable and to get it back out, or is it once it's rendered, it's like for labels?
Yeah, so text is obviously one of the Achilles heels of WebGL and OpenGL. We have an experimental text layer that's pretty good. It's certainly not interactive. If you want the interactivity, you're probably best off at this point putting a DOM element on top. We do have various solutions of overlays that can actually position DOM elements using geospatial coordinates. So you can actually have a DOM element that moves with the rest of the map and stays in sync, but obviously it won't respect the Z buffer or be hidden or like the rest of the 3D graphics. So there are limits to it. Right? Anything else?
Okay, mind equals blown. You guys are doing some awesome stuff, man, for real. Do you get to ride Uber for free? Do you have to pay? Huh? All right, so I think next up, have you guys heard of Three.js before? Yeah, so yeah, it's a library, WebGL related. So here we have Ricardo Cabello, aka MrDoob, up. And oh, before I forget, I want to thank the Kronos Group for sponsoring tonight, paying for the pizza and everything else. And they're awesome, amazing people. And they'll be with us at GTC coming up next. So, MrDoob.
All right. Hello, everyone. This talk has been extremely improvised. It's going to be very improvised. So yeah, we'll see how that goes. I'm not going to talk about Three.js really. Well, I don't have any updates. I mean, I was supposed to finish a new version today and write the changelog and all that stuff. So somehow, as a distraction, it seemed more fun for me to kind of like. Sometimes I realize that because I'm all the time on Twitter looking at WebGL things and WebVR things, I probably like see a lot of things and then I expect everyone to, you know, you have seen this thing or this other thing. So I'm just gonna do a little bit of an overview of the things the latest things that I have seen in WebGL and WebVR and WebVR. I'm just gonna share that with you a little bit. So I'm just, yeah, the idea of the talk was like kind of like the WebGL web and the WebVR web. So to start with, I'm gonna also wanted to show how like the web used to be 20 years ago, just as a contrast of how it is now. So the WebGL web, like, used to compare it like the web used to be before. So this is, I found it on a Rhizome website. They have like some of the NeoCities websites that rescue some of them. So. This some people like. Here's another example. This one was kind of dark. Anyway, so today. That's actually it's a website. It's a WebGL website, and in a way, like that, you know, what I like about this is that it shows that we are. I don't know if I can stop this anyway. We getting to the point that WebGL can do like things like we used to, like crazy things that we used to have like 20 years ago, but like now it's getting easy enough so people like, oh, I had this idea of like just putting these random characters to dance with each other. Sadly, like apparently it took him like 7 months to do, like to actually get to do it. So yeah, you can just move them around and select whatever, you have different dancers. You can change the music, whatever. And another example. It's interactive. endless. Anyway, so this kind of a level that is easy enough for people to do whatever idea they have. Even is I think it should be even easier at this point. But this is like one of the more proper examples of WebGL. So this is like one from today actually. Like this is for Southwest, and on this website you actually scroll like a normal scroll website. And then the idea is like you can listen to the people talking about the experiences or flying with them. But like they use I don't know how to close this actually. There you go. They use the normal paradigm of websites for scrolling, used to scroll the website, but just further into the content basically. I guess it's gonna be, I don't know. It's gonna be, I don't wanna get dark. This is a kind of something like I come from this world called the demo scene where people used to compete with each other, and this may take some, I don't know, we'll see. Used to compete with each other, and they still compete with each other, showing computer graphics and showing what they can do with a computer and generating computer graphics in real time. And I don't know why this is taking so long, but like it has taken a while. Like it's a funny world because they are always showing like the newest, at least they do use the latest like GPUs and stuff, but they're always very, they just use like Amigas and Windows, or like they don't move out of there. So they actually were always not very open to WebGL in general, because WebGL is like it's JavaScript. Like they want to, they want to really have control of the code that is happening. They want to write in C and they want to write in assembly, whatever. So it has taken a while, like 7 years or 8 years. But like now, finally, like things are getting fast enough for like the new generation of people that are doing demo stuff. That like the new people are like this is an invitation for one of the biggest demo scene events, and they actually did it with like us at WebGL, and the website now is in WebGL. But like so, you finally, it's been a little bit of they've been opening a little bit to Unity and also WebGL, and I was afraid that Unity was going to be first on like for people to do like an invitation for like a thing, but like finally like WebGL kind of won, like, yeah, we'll see. But yeah, like this is I'm not going to show the whole thing, but like it's a little bit loud, but kind of shows the kind of things like used to people do these days. So they're still like they're mixing with design a little bit too, but. So I think that kind of shows what people, yes? That was all real-time code, just not a video. Yeah. They have their own editor for their own little Flash for creating the whole thing. But like like people are starting to create their own tools, their own like node-based tools to like generate these things, because the runtime like WebGL on the browser is there. It's a matter of like creating those tools that, and it's easy enough that people are creating their own thing. They don't require to have like a main one or like a, Adobe to create a tool for them, kind of. But yeah, all that stuff is just, I think it's maybe like 5 or 6 guys in Sweden, Norway. White people. This is another example. Like this guy is only like, he just had this idea of just doing this website. It's only, doesn't really explain anything. This is the start of the website. So eventually eventually you figure out that you have to, you can move this character around. Actually, you don't have a lot of interaction. You can just go forwards or backwards. So basically you had to stop and grab like people that are waiting, go from station to station. That's the whole idea of the website on his project. But yeah, like he just had the idea, he just did all the drawings and created this kind of experience that was beautiful, very beautiful, I think. Another interesting thing has been that, for instance, until now, most of those things are like, everything is in WebGL. Everything is like in a canvas there is no HTML around it. It's not a good thing for the web to like end up with a website. Everything is inside pixels. Like there is no like browse, like if someone is blind, cannot really see anything on the website. So the next websites are a little bit more of like how people are starting to use WebGL, but like to enhance the actual HTML website from front of it. An interesting one, like a funny one, is this one where these leaves on the background kind of like get affected by the content that is on the front. So as you can see, like when pushing those things, which kind of like makes it interesting, it's like interactive background, I guess. But like this is still like a normal website. It's only like it has a image on the background, like a WebGL on the background that is interactive. This one goes further, like pushes that idea even further to the point that you don't know what's HTML and what's WebGL anymore. like this is just a website for a director in Japan, and from section to section you just scroll and the whole thing kind of slides, but like this is still like a normal HTML text, but like somehow they slide it. I don't know, like it's starting to be very like masterfully done, but to the point like this is still like someone like search can find them, but like everything is still like very well mixed together. Like that's how, even you can go, I think it's this one. Yeah. I think it's this one, there you go. Yeah. This is, I don't even know how they do it. Right, so that's kind of like the overview of what I've seen lately from WebGL. For WebGL 2, like sadly, at least myself, I haven't really followed it too much because last year I was mainly like focusing on WebVR, because I thought it was a little bit, the web had to like make sure they will catch up to what people were doing with VR at the time. So for those of you that don't know,
VR should be accessible to everyone, because it has the potential to let everyone explore, play, and create in amazing new ways. But right now, VR is pretty complicated. To make awesome VR stuff, developers might have to learn a new language, and then spend a bunch more time to make that stuff work on multiple headsets. And then when we want to play with their awesome VR stuff, we've got to have the right headset. VR should be easier, so developers can make something quickly, and share it with everyone, no matter what device they're on. Kind of like how easy it is to share stuff on the web, but with VR. Well, that's the idea behind WebVR. It's VR on the web, for everyone. Here's how it works. Say you're in a browser like Chrome, and you come across a WebVR experience. You just tap the link, put on a headset, and boom, you're in VR. Developers can build WebVR things the same way they build web things, with JavaScript. And since it all works in a browser, it's easy to make it work for all kinds of VR devices, whether it's someone using their phone, their computer, or their entire room. Developers are already building and sharing awesome stuff with WebVR. We've started showcasing their work on a site called WebVR Experiments. It gives you a glimpse into the kind of stuff that's possible. You can play simple games, see the world in a new way, explore interactive stories, play with a friend, or lots of friends. Each experiment comes with open source code to help others make new experiments, and developers can submit what they make. All of this is an effort to make VR more accessible, so anyone can build and everyone can play with awesome VR stuff. So come and start playing at webvrexperiments.com.
So that sounds like very easy. Oh, like I think they showed this, or they released this like summer last year, and the code, at least the code that we had on 3 was the API that we had for doing WebVR stuff. In 3 was not easy at all. Like you had to like understand what's the rotation of the headset, what's the you had to have a stereo. You had to like know that you're gonna run it to 2 eyes, and it was not easy at all to do. So like I spent like the second half of last year pretty much like trying to like make an abstraction like in the same way that like WebGL is complicated and you need to put an abstraction on top of it. Like WebVR is kind of complicated that way, and you don't want people to be like, don't worry, like you don't look at it, it just enable it, it just works. And there is also even more complicated because they're like kind of like 3 different versions, and the version that we're using right now is not even like the one that is going to be in the end. So yeah. But like nowadays, like I managed to like get it to the point like if you like know 3.js stuff, like it's basically to the render you use, and it has this VR property object, and you just enable it, and then but you need to like tell the device that you're going to use for rendering, which VR device you're going to be rendering to, and you also need to like pass a function that is going to be the one that is going to be for animation. Like those, especially the last one is probably the thing that people bump into most, because until now you'll have your own animation loop somewhere else. Now you need to tell the renderer which animation loop you want to use, because when you are into VR, you have to use a different animation loop from the system basically. But like I managed to get to those 3 lines, and I hopefully it should be like simple enough that even a new version of the WebVR API is going to be, I'll still be able to hide everything that is happening underneath, so you don't have to worry about it, and just enable it and it will work. So what I've been kind of like focusing more like last year was on the mobile version of the WebVR. So as a quick overview, also I like kind of started with Google with Cardboard. This is a little bit how which for those who know, you don't know, this is how it looks like. And this is kind of the experience that you have right now on a phone, which I think Cardboard, or like phones that support Cardboard, like most, then the idea is that any phone that should be able to do this, like you don't need like a Daydream or anything like that. You should be able to have something like this, and as long as you enable, as long as you install on obviously this is on Android only. As long as you install a what's the name? VR services application or something like that. Oh yeah. But yeah, so you just go to any website and select, in this case it will be the 3.js examples, and you just click on enter VR, and then the whole thing automatically just goes into, you're already seeing VR probably. So this is how it looks like, and then you just slap it into the Cardboard device. One of the better examples was also for the WebVR examples was this one where, on Cardboard you don't really have a controller or anything, but in this one they managed to do this game where you're looking where you want the character to go to, and out of that interaction they can make it so you had to go around this or the characters to catch them basically, or kill them, I guess. But even with that simple interaction, it was pretty good for kind of basic, for how limited the Cardboard is. I actually even figure out there was this version of the editor. I figured out that you actually, because I added WebVR into it, you can use this is my phone and using the editor from the phone and adding things, and you can go into VR from inside the editor in the mobile basically. like it's not really that useful, but I'm sure I don't know, it just works. It's just amazing that it works. Like that's what you get when you do something on the web native, I guess. I guess you can like prototype stuff. So then like Daydream View came out like 2 years ago, where now you have a controller. So so basically that allows a little bit more interactions into it. So basically whenever you go, you put the phone into the device. You have like, in this case, it will be like this is a normal like Daydream experience where you can select the options, select the experiences you want to have. But like this is the, I don't know if it's this video maybe. Oh, and this is probably one of the best examples of best applications that I have seen using the controller, SVVR. Let's see if I can, I don't know if I can, oh. Where are the controls? Oh well. Can I go? Maybe it's like at the bottom. This game basically introduced one idea. Like the problem with the controller is that you can only like aim in 360 around you. You don't have position. So this game like show how you can select things and drag them by like pressing or like clicking on it, but like also like sliding the finger on the touchpad on the top. So then that way you can start to have a little bit of a control, like more like a 3D-ness of the whole controller. And like, yeah, like this is also one of the first examples, one of the first projects that I saw for Daydream, like uses this technique of like this kind of like bending controller, bending rope, because there is a bit of a delay on the Bluetooth controller. So by just having that is good enough for you to like not really be it works pretty well for what it does. This project actually, this game is pretty good actually. You can go into VR, and like you keep going into VR by finding different headsets that you put on yourself, and then you go on basically you get a headset and you put it in your face, and then you go again into, it's the same thing, like then you take it out. You just point your face and then take out the headset. Don't remember which one was this one. Right. So there's an Oculus browser already for Gear VR, and there's also the Samsung browser for Gear VR. But like the one I've been like playing with and like kind of testing a little bit has been the Chrome version of it. So whenever you go to this is just basically you're on the phone again, and you just put the device on the Daydream View. So whenever you do that, you end up in basically a version of the Chrome in VR. And like the same website that you were looking, well, it gets mobile mode though, but it basically like behaves, at this point it behaves like not like just a normal website, and you can like, you cannot really type text right now. There is no keyboard, but it's enough for like to be able to like scroll and like select things and go into VR and all that. I've been focusing a little bit, especially on mobile, because I think it's the most accessible right now, and I think especially like this year that Oculus is releasing a headset that for $200 it includes already the phone, I guess, the phone part. I think is probably going to be like what most people are going to like experience. So the easiest or the earliest we start to get like pretty good experiences in mobile VR, the better, and then we can, all those things will like translate into they translate into desktop. For desktop VR, this is kind of like, I haven't really followed too much. The different people has been working more on that, but this is the one from yesterday that it was kind of fun, I guess. So I guess it's yeah, that kind of thing is the kind of thing that they can do, but we still need to do more tools for people to play. Like right now, this was pretty creative to use that for running, but but still had to like create more tools to allow people to do more things. And something I've been playing a little bit also is with WebVR. At Google, there's this team trying to explore like AR on the web and how that will look like. And they've been, so far they've released those two browsers, WebVR on ARCore and WebVR on ARKit. And they're basically like a fork of Chromium using the ARCore one, which is the Google one. And I think it was WebView with some hackery for the ARKit one. And then like enable like some like basic APIs for like kind of like talking to ARCore and ARKit, but using the same language basically. And they also done like this wrapper on top of all this stuff to make things easier, which kind of like sits on top of 3. So something I haven't been able to play too much with it, but like something, especially like something that we're working for the version that I'm trying to get down of Three.js, hopefully next week. Like now we have a pretty good loader for FBX to the point that you can like load animations from Mixamo pretty well from Adobe Mixamo. So this is one of the examples that we're working with. So one of the quick tests that I was doing, that I thought to do with WebVR was like basically have like this, this like now loading these characters it's just a couple lines of code, so it shouldn't be like too difficult to like using this WebVR and ARCore fork or like this browser. Like it was very easy to like basically do this thing. Like the 3.3.ar.js allows you to raycast the scene, and it tells you where it's finding it, and whenever it tells you the position, you just add that object there, and then the rest is just similar to VR. Like you use a camera that's going to be, you don't have to like care, you only care about the scene, you only add things to the scene. All the code on top will just take care of the right, like making sure that it's there in the right position. So that was one test from earlier this week, and then a friend of mine saw this, and he actually had a scan of himself with bones and stuff. So he sent me his model. And well, yeah, like I obviously like I know where to put this code, and it was fairly easy for me to set this up. But hopefully, like hopefully at the beginning of this year, we'll have like more tools so people can do the kind of things that are, the dancing part from the beginning. Well, that guy's actually kind of like inspired me to work on these, because he wanted to put those things in AR. So I just did the code. So like here, there's the code. You just do the rest. But yeah, that's about it. But yeah, that's a bit of an overview. If you have any questions about anything, like it can be 3.js related, unless it's a program that is not working or something.
So are you working with the AR 3.3.ar.js?
Yeah, I'm so far I'm using the library. I'm just giving them feedback, but I'm not working on the API itself. I'm just like trying it a little bit. Like I'm just like there's some teams at Google that I can try to help. I have experience in building APIs, so I'm trying to like help them with that. But yeah, or like so I'm just testing it and trying to doing experiments to see like, oh, this is like for instance, actually something that I found doing those experiments is that the 3D is very crisp compared to the background. Like the camera is kind of blurry, but the 3D is very crisp. And you want to make it more integrated, the 3D needs to be blurry. So one thing was like, I tried to, like while doing that test, I tried to remove now all those devices have like these high DP, like Retina displays that 3 takes into account. So I tried to disable that, and then things broke. And so it was like a thing like, you need to test and do experiment to try it. But yeah. Yeah.
Depending on focal length, it needs to be blurry.
Yeah.
Focusing on it,
then it was
clear, but if you're not.
It was more like in general, everything is blurry through the lens, I guess, like compared to the sharpness of the 3D. But it was more of a matter like by getting rid of the pixel ratio thing, like the background, somehow it was doing a zoom. So somehow the background image with the camera was not taking that into account. It was like much bigger than the phone itself, so it didn't match anymore. But yeah, like that's things that I found, and I'm hopefully I'll be fixing for them, or like I'm helping them. Yeah.
Any plans to use TypeScript?
For 3, I guess. What we are trying to, or what, like, TypeScript, like I really like TypeScript since it was released. The main problem is that right now I think we have a good momentum in general because a lot of people know JavaScript. And I come from ActionScript 3, so going from ActionScript to like JavaScript was like, oh, I want my types, but you know you get used to it after like 7 years. But there is people that are trying to use, they have problems trying to use like 3 with TypeScript setups. So there is this, what's the name, the define type thing. I think there is a way of basically what they need is a way, like I think it's a type of JSON that you generate all the information. It's a .dts or something like that. So we want to make a way that generating that file is automated, or like it is part of the, is always up to date. So that's kind of like will be the first thing. But like right now we still have more problems on updating JavaScript to like the latest JavaScript, and now like I think changing the whole thing to TypeScript will be too much of change at this point. But yeah, we're trying to make sure that it works for everyone, kind of. Yeah. Wow. Right. So right, yeah. So he's asking how long it's going to take for the controllers to also, for WebVR to also support the controllers, because right now WebVR is focusing more in only the headset and like the telling basically like the information about each lens and like all that, all on the rotation and position, but not so much in the controller. Right now, every controller is different, and like mapping it is very like, you want to have like an API that tells you like, I want the button that does a click thing, and to make that click for all the controllers. So they're a little bit behind on that. I think right now they're trying to like focusing more on the headsets. Probably, I think by summer they will know what the situation. Right now you can use the gamepad API, like they've modified the gamepad API to do that, but I think they're trying to first get that to work, the headset one, which yeah, but like they want to make the controller stuff be part of the WebVR itself. Right now it's just like, yeah, it's just hacking to the gamepad API, which is a hack because the gamepad API doesn't give you events. So and sometimes in order to like, if you're in VR and you want to like play music, music on the web requires events, user events, and because the gamepad API only gives you zeros or ones, that's not an event. So they do have like needs for fixing that, because right now we're hacking, we're doing weird things for that. But hopefully like summer, well, no, but like, yeah.
I didn't understand what you meant about how you have to set up a separate render loop whenever you go into WebVR.
All right. So
what was that about?
The thing is, right now, whenever you go like websites in JavaScript, you have a render loop. You have a what's called the API is called like request animation frame, which basically gives you the next frame of refresh of the screen, and that this screen goes, for instance, at 60 hertz. For the device, screen goes at 90 hertz or 120 hertz. So it's not the same system anymore. So you actually, so you cannot reuse the same request animation frame from the JavaScript website or the website itself. You need to use a request animation frame from the device. So it's not so when you try to, if you try to render using that request animation frame from the website into the device is going to be black because it's not, at some point it was working, but like eventually like no, we need you to, we're not going to display anything on the device unless you use the request animation frame that we give you from the device.
Can you pass the device object in as an argument to the request animation frame?
No, it's
a property or an
Yeah, like it's basically like until now we have been using like window the request generation frame, which basically maps the request generation frame. Now you have to use device the request generation frame. So the reason I did that was just to hide it, because you never know when you are inside VR or not. So that logic is just easier, because sometimes you may be. Sometimes like the WebVR is running even if you are not in VR. Like it may be just like a phone that is using the same API for rotation, but then in that case, which the request generation, it's, I don't even know. Like, so it's easy just to hide that, so it's a little bit more automatic.
Exclusive? You don't have
Yeah.
both going at the same time.
Yeah, they switch from one to the other one. Make sense? Yeah. So they're doing an extension. What's the name of the extension? Yeah. So like until now, things had improved. Like at the beginning, the beginning of last year, we were rendering the scene once and then another time. So that was like kind of. For like big machines, it was fine, but for mobile, you will see that it was slow. So part of the whole refactoring was to make it like, at least whenever you draw, if you draw one cube, you render one. So you render the scene both at once, but you still have to do 2 draw calls, basically. For like the new extension that is also going to be in WebGL 1, basically it's going to allow you to do both draw calls using a single call, basically. So it will be like you're drawing once the scene. But yeah, it's any idea when it's coming or anything?
It's being actively worked on.
Right.